Hi everyone, welcome back to the workshop. You know how much I like repairing old test equipment in the workshop. Well, today I've got another repair. However, it's not a very old device. I bought a brand spanking new Alesis MultiMix4 small 2-channel mixing console, and I actually use that when I'm wanting to mix in some screenshots, some video screenshots on the PC there into my videos, and I use the MultiMix4 to interface an external microphone, so that I can basically annotate the videos with my voice, etc. So I bought this MultiMix4 off of eBay, brand spanking new, and I'm playing about with it. It's working not too bad. However, I decided to change the microphone and buy something a bit better, so I actually ditched the cheap normal vocal microphone you would use in bands and that sort of thing, and I went and bought one of these little desktop microphones here. They're omnidirectional microphones here, but the thing about these things are they're phantom powered, which means they require a 48 volt supply effectively to work. So plugged that into the MultiMix4 and I was getting horrific background noise. So noisy it was, in fact, that the LEDs on the MultiMix4 were off the scale. So wow, I thought, well, maybe it's the microphone, so I swapped it with another phantom powered one that I happen to have lying around, from over the years of playing in bands and that sort of thing, and it was exactly the same. So I determined that there was actually a problem with the phantom power circuitry within the MultiMix4, so no choice, I'm going to have to rip it apart. So here is the MultiMix4. Effectively what you've got, it's just a simple 2-channel mixer. You've got the inputs at the top here, either XLR or guitar line input style things. You've got a couple of gain controls, you've got an EQ section here and pan controls, and then the main output level from each of the channels into the main preamp circuit of the device. And from there you've got a main control, a main volume output, and a headphone output. And as you can see, you've got a couple of LED bars there for each side, and then you've got the main outputs there and the headphone output there. And of course you've got this phantom power switch in the middle, which is what I've got all the problems with. It does light up. If I switch on the MultiMix4, you can see that it does actually work. I do actually get an LED showing phantom power. However, there's a problem. So I'll get it over onto the workbench, we'll demonstrate the problem, and then we'll open it up and we'll see how we go from there. What I've done is I've hooked up the microphone to channel 1, and I've got a multimeter just across a couple of pins on channel 2, just so that I can monitor the phantom power going to the microphone. There's a phantom power switch here which just basically turns on and off the phantom power for both channels 1 and 2. So I should be able to monitor that and have it live as well via the microphone. And let's see if we can demonstrate the problem now again with it on the workbench. Phantom power's off at the moment, and I've got the microphone hooked in, and I should be able to see some activity on the LEDs. Of course, you won't really see much. I'm tapping the microphone there. You won't see much because the phantom power's turned off. So let's turn on the phantom power. And as you can see, the LEDs are almost full up. The microphone is now actually working, because if I just tap it, you can see the LEDs flashing. Now if I turn down the gain on channel 1, just down a little bit there, you get probably a better idea of it working there. You can see as I'm talking, you can see that I'm actually getting a signal there, but you can see there's a hell of a lot of background noise which is shown on the LEDs, and the more I turn the gain up, the more the noise floor is so high it's actually maxing out the channel. So what I've managed to determine, if I turn off the phantom power, immediately the noise floor goes away, and as I'm talking there you can see just for a few seconds there before it dies away, I've got no noise floor or a very low noise floor, and I'm actually getting something on the LEDs. Let's try that again. So that's it powered up. You can see I've got a noise floor there. I'll just turn the gain up a little bit, so we're just about into the red there. I'll turn off the phantom power, and I'll keep talking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What you can see happening there is, immediately I turn off the phantom power, the noise disappears, and I'm getting a good response from the LEDs, from the microphone, until it eventually dies away. Now if I look over at the meter there, if I turn on the phantom power again, you can see the phantom power is way up at 70 volts. It should only really be round about 48 volts mark. And what I've determined is happening is, if you turn off the phantom power but look at the meter this time, oh, just get that there. Turn off the phantom power, you can see the voltage dies away slowly, and when it's down below your 20 volts mark, something like that, I'm getting a good response from the microphone. So what I think is happening is that the phantom power is far too high. As soon as you switch it off, obviously then it's relying on some capacitor somewhere that's storing some voltage, and it's that's releasing over to the microphone, and it's when it falls below a certain point, the noise floor disappears, and I'm getting, you know, a good response from the microphone. So what I think's happening is, there's either the phantom power's voltage is far too high, and that's overloading the circuitry there and giving me a hell of a noise floor, or it's a very noisy phantom power. That even though it's a little bit high, it's very noisy, and as soon as I cut that, I'm getting a much more stable voltage to the XLR in terms of phantom power. Even though it's dying off, it's a more stable, noiseless phantom power. So what I think I need to do now is see if I can scope the circuitry round about the phantom power generator and see what we've got there. Okay, here's what I've managed to determine. Working backwards from the resistors that provide the XLR with the phantom power, basically that comes back along a track underneath that pot there, and it's this pin here that basically comes from the main input board up onto the control board up here. So this link here down onto the main board is actually the phantom power, and looking at that on the other side, let's get the camera up on here, you can see, following that round, there's a nice big track for the phantom power there. That goes all the way up there, and these two pins are the other side of the LED and its resistor there, its series resistor, coming off of the phantom power switch. So that there is basically the phantom power there. So that's the output of the switch. The input from the switch is these two pads on the other side there. So what I'm going to do is I'm going to scope that, and we'll see what happens. Well, first of all, actually, I'll scope the output from the switch. So this is the phantom power. I've actually on scoping that. I'll just get down onto there. You can see I'm just on the output from the switch, just right by the resistor that feeds the LED. So back onto the scope, there it is there, and the phantom's power switch is off. If I turn it on now, you can see it goes up to about 70 volts. I'm on times 10 at the moment, my times 10 probe, 2 volts per division, so that's 20 volts per division, so actually it's around about 60, 65 volts, something like that. So I'm now on the scoped the input to the switch. Can't show that in the PCB, it's off camera at the moment, and I'll just turn off the phantom power switch, and you can see the voltage goes up even higher. So obviously when the switch is in the on position, it's loaded up slightly, so that I'm nearly getting 80 volts there, and I turn on the phantom power and it drops down, it dips down, and then it settles. So I think the whole problem is this phantom power is far too high on this board for some reason. Okay, so what I've done, I've traced the phantom power, basically working backwards from the power side of the switch. It's back along here, that pad there, and it goes along here on the underside of the board, then it goes down one of these jumpers here, down onto the, I don't know if you can see that, there's quite a big resistor in there. That's basically, that's basically the resistor that's feeding the rest of the circuit with the phantom power. And turning the board over, on that side of the board. On this side you can see there's actually 4 surface mount diodes there going across the way, but you can see there's some rather large pads across the diodes, and those are actually these rather large electrolytic capacitors there. So what I think we've got there is a voltage multiplier circuit using diodes and caps. Basically there will be a square wave or something like that being generated at this end of the circuit, basically feeding possibly just the 4 diodes and 4 caps to step up the voltage there. So I suspect possibly that transistor there is maybe doing the initial switching, feeding that part of the circuit there. So there's possibly what the circuit would look like. This is a small half wave voltage multiplier. You can see I've got a square wave or some kind of switching waveform coming in here, and AC coupled straight away. Then I've got 4 diodes there and 4 caps, and then at the top end here I've got basically a DC output, and I've got that big large series resistor at the top there. So I'm figuring with the 4 diodes underneath the board and possibly the 4 caps, this is probably what I've got. Unfortunately I don't have a schematic diagram for the MultiMix4, so I'm kind of winging it here, but this is probably what it looks like. I haven't actually had a look at that transistor on the board, but possibly it's switching basically here and feeding the signal in here. So what I think next thing I want to do, I want to see how stable that switching waveform is there. There's not a lot to go wrong on a voltage multiplier like this. It's only caps and diodes. Really it's either going to work or it's not going to work unless there's some intermittent fault. But certainly I'm getting a drop in voltage here every now and then. It's like it's going from like 70 volts down to the 20 odd that I was getting, and that's without a load, and I don't really see much of a load other than some resistors at the top end of the circuit where it feeds the XLR connectors, but I don't think that would cause the problem there. I think I'm probably more likely to have a problem round about here, possibly the signal that's feeding this here. So I think the next thing to do is try and scope it and then see if I can make the phantom power go up or down and see what sort of effect I'm getting here on the scope. Okay, a little bit more investigation. What I found is that transistor that I was noticing there has got nothing to do with the voltage multiplier circuit, because the signal that's actually feeding the voltage multiplier is basically coming direct from the AC input. It's probably one of the reasons why this MultiMix4 doesn't run off a DC regulated power supply. It's running off a 10 volts AC power source, and it's basically just taking one of the AC signals there directly from the input connector on the board directly over to the first series capacitor on the voltage multiplier circuit. And what I notice sometimes when I'm switching off and on the phantom power, that the phantom power voltage is not that stable, i.e. when I switch it off it always goes to 80 volts. When I switch it on, sometimes it's 20 odd volts, sometimes it's 60 volts. What I was finding is that that voltage is directly proportional basically to the AC input. When it's very high, I'm actually getting about 11 volts AC on the input power connector, and when it's down about 20 odd volts I'm getting about 9 volts AC on the input connector. So something's, when I'm switching the phantom power on and off, it's loading up the power supply basically, and when it's sitting at 9 volts, that's enough to drop the voltage down on the voltage multiplier circuit, just enough that the phantom power becomes within spec, as it were, and I get basically no noise floor. So as you can see here, when I stop talking, it's basically quite good, it's quite low, the noise floor is quite low. And if I then, I'll just get my meter on here, I've got it on AC at the moment, so I'll just go across the input connector there, and looking at the fluke, it's basically 9 volts AC. It's quite low. If I just switch the phantom power off and on until I get the noise floor back up again. Okay, that's on now. You can see the noise floor is suddenly a lot higher, and I haven't changed anything. I've just basically switched the phantom power off and on, and if I go across the input pins, 11 volts. So that extra 2 volts seems to be raising up the phantom power. Why that is, I don't know. Wish I had a schematic so I could trace it more. So I might actually try a little bit of a fudge, maybe. I might try putting a capacitor across the output from the voltage multiplier. See if I can stabilize it there, and see what that does. Okay, so what I've done is I put a large 100 volt electrolytic capacitor across the output from the main phantom power supply resistor there, and then across that capacitor I've put, I'm actually using Jerry Sweeney's decade resistor box here. So basically it's open circuit at the moment, and as you can see, quite a large noise floor there on the phantom power, and off camera I'm getting about 20, 40, 70 volts, something like that. So if I just stick it in here, I'll put a 1k load across the phantom power. Let's get it in there. You can see it drops right down. The phantom power, although it's rippling quite a bit, it's down at 40, 45 volts there. And as you can see, noise floor is virtually right down. So that's just putting a bit of load on the phantom power. What I'd like to do now is actually hook it back up to the PC and see how noisy it is, see if I'm getting any background noise from the phantom power basically leaking into the input there, because you know it is rippling by 10 volts, something like that. You know, it's going from about 40 to 50 volts there. Yeah, you can see I'm getting a little bit of noise floor at the bottom, but I mean I am using a pretty sensitive mic, a condenser mic, and I have got the gain quite high. You know, I'm some way away from the microphone, yet I'm still putting it into the red with my voice there. So I think next job is let's hook it up to the PC and see what we get there. Okay, I've hooked up the main output there into the sound card in my PC, as it normally is, and I'll just turn this around onto the actual PC. You can see I've got sound recorder running, just doing a basic test. So if I actually just go back over the microphone, 1, 2, 3, 4, you can see it responding up on here. So I'm actually going to start recording now. 1, 2, 3, 4, 5, 6, 7, 8, test, 1, 2, 3. Stop recording and save it to my desktop. Yep. And open it up. 1, 2, 3, 4, 5, 6, 7, 8, test, 1, 2, 3. That's actually quite good. That's not me, that was the PC playing that, so I'll play it again there. 1, 2, 3, 4, 5, 6, 7, 8, test, 1, 2, 3. So it's definitely a lot better. It just, you know, for some reason I'm having to load up the phantom power voltage in order to stabilize it. It looks like possibly it's not got enough of a load, and basically the unstable output from the voltage multiplier there is just drifting up to, you know, too high. And I mean, I've just got a 1k load there. I think I'll just try changing that. If I just pull the load, and there it goes. It just it's alright for a while, and it suddenly jumps up. 6k is the magic resistance value just to stabilize the phantom power and bring it back down to, what's it at the moment? It's still 60 volts there. Okay, so what I've tried now, I've got rid of the load resistor. I thought I'd try something a little bit more stable, and I've actually put 3 zener diodes in series across the phantom power basically I've got a couple of 20 volt ones and a 9 volt one. So there you go, 49 volts, which is not far off the 48 volt target for the phantom power. And a little bit warm. I'd probably need something quite a bit higher wattage there. I can't leave it on for too long, but you know, that's definitely a lot better there. Of course, I don't know what size my series resistor there, so I've just kind of hacked on the zener diodes without doing much of a calculation to see if I got the correct resistor, you know, for feeding the zeners there. But it does seem to be working. Okay, so I clearly need some zener diodes a bit more powerful there, higher wattage. So looking through my bits bin, my old diodes bin, I've actually found, let's see, what is it? It's a 1N5364. That's a 33 volt zener diode, 5 watt. So we'll try that and see how we get on with that. Okay, that's it sitting in place there, if you can see that. So we'll switch on the power. And we're getting about 30 odd volts on the, basically the feed resistor. So it's definitely clamping it at around about 33 volts. So I think I'll just let it stabilise there for a while in terms of temperature and all the rest of it, and monitor the temperature of the feed resistor as well, because obviously that's going to, because I'm dissipating some current now, I need to watch I don't draw too much current through that feed resistor there. Still too warm. I maybe need to try something slightly different, like possibly another series resistor. I've got to watch I don't get too much of a volt drop on the phantom power. However, it's not meant to draw much current at all on you know, the actual phantom power current to the actual microphone at all. I forget the specs offhand, but it's you know, it's in the order of milliamps really. Okay, I thought I'd cheat here. I found a little zener diode calculator online, so let's stick in the figures. So I'll just say 80 volts for the maximum input voltage, and we'll just say 60 volts for the minimum output voltage, 33, and the maximum load, I figure 50 milliamps. Phantom power maybe 10 milliamps max per XLR input. Then you've got the LED and all that bits and pieces on it as well, so let's just say 50 milliamps. Calculate there. It's telling me I need a 4.7 watt 470 ohm series resistor there, and I'll get away with 33 volt zener with a rating of 3.45 watts. So the one I'm using is 5 watts, so that's great, that'll do nicely. So I just need to go and find a 470 ohm say 5 watt resistor, put it in series there, and we'll see what happens. Okay, raking in the parts bin again. I found a couple of 470 ohm 5 watt resistors there, so we'll just uncouple these two and just slip one in place and see what happens. Okay, so what I've actually done now is I found another 15 volt 5 watt zener, so I've actually put it in series with a 33 volt one. So I'm, you know, getting the zener voltage, you know, quite a lot higher now. So, you know, I'm approaching the 45 volts or so, measured at, you can see I'm measuring basically across the zener here on this clip here. And obviously it's very, very stable. There's no rippling at all, because that's been basically being smoothed out by the clamp. And, you know, my diodes are a little bit warm, which, you know, would be the case, and I'm not really sure how much current's being drawn, like I said, from the circuit. But basically all it's doing is feeding some resistors at the top end on the XLRs and basically LED. There's not much else to it. I can't see the phantom power supply being tapped off for any other purpose along its way across the two boards, but not to say I haven't missed something. There is actually a load resistor. You can just see, if I can just get in a bit closer there, there's a tiny little load resistor there, but that can't be much of a load. It's a, you know, it's a pretty low wattage resistor there. So I'm not really sure. It's just basically trying to clamp down there. Now I've left the resistor at 470 ohm. It should be, you know, quite a bit less than that now that I've basically got a 48 volt zener diode set up. Should really be around about the 200 ohms mark, given that 50 milliamp load that I'm looking at. However, you know, even with one mic connected there, I'm getting a very, very stable, you know, 48 volts or so phantom power voltage. So I think I'll just probably just leave it at that. You know, it's a bit of a hack what I've done. You know, maybe I should have spent a bit more time in trying to repair the circuit properly. But yeah, you know, I think for what I'm using it for in the workshop, I think it'll be, you know, be good enough there. Just got to watch the temperatures are not going up, you know, too much. Probably what I should do is you know, use some higher rated zener diodes, but I think this will probably do for the time being. I'll get it up and running at that and we'll see how it goes. So next step, I suppose, is to box it back up and get it back onto the PC and see how we're going. But just thought I'd measure the phantom power voltage at the spare XLR, and well, there we go, 48.9 volts. That'll do me. So let's strip it back down again and box it back up. Okay, so there we go. That's the MultiMix 4 back up and running. I've got the new microphone hooked in, as you can see over here. I've got phantom power switched on, and if I just shut up for 1 minute, you can see in the LEDs there, basically I've got next to nothing. And I do actually have a gain at about 50% there, and the main line level about the same. So yes, it's definitely a lot better there. In fact, the gain's probably a little bit too high. I'm almost at the point of clipping, and I'm about 2 feet away from that you know, desktop mic, so it's definitely working pretty well. So all I need to do now is tidy up the wiring a little bit, push it back into the corner of the desk there, and that'll be it, good to go. But you know, it's par for the course to buy something off eBay, brand new, and you know, there's something wrong with it. But you know, sending stuff back and getting you know, replacements just isn't my style. If you know me by now, you know I like to just get into it and, you know, make it work, repair it, do what's necessary, get it up and running. It's always interesting to take the cover off of something anyway. So you know, there we go. So we'll give it a test with the PC, make sure it's recording, you know, good enough. You know, I don't want any background noise, as I said, but don't anticipate that. It was working fine with before I put the cover on. So job done. Thanks for watching.